Hello, my little mathematicians. Today we're going to review ratios and rates. So let's go ahead and get started up at the top, and we'll define the definition of a ratio. Remember that a ratio is a comparison between two quantities or things. Okay, so if they say quantities, just it's two different things, which brings me to a point of I know that ratios are like fractions, and so you'll want to reduce the fraction. Like if it's like 4/8, we know that that reduces to 1/2. Okay, so that's no problem. But if it was the other way around, like 8/4, you know that that's 2 to 1. And our initial habit is to reduce a fraction to just 2 if it was 2/1, right? But yes, a ratio is like a fraction, but for a ratio, since it's comparing two things, if we just have it as a 2, it's like two, like let's say we're saying like cats to dogs, two cats to how many dogs? Like zero? What's on the bottom? So we want to keep it as a fraction. So we don't want to reduce 2/1 to just 2 for this. And then also the other thing is, let's say it was like 5/3. Okay, well, yes, I know that 3 can go into 5 once with the remainder of 2/3. So like 1 2/3 is equivalent to the fraction of 5/3. You're right. But I don't want to necessarily reduce this to this because remember the top is talking about something and the bottom is talking about something. So here it's like, well, is there like two dogs and three cats? And then do you split the one in half and add half to each one? Or what does this mean? So we don't want to change these to mixed numbers. Okay, we just want to keep it like this. So remember, ratios are two quantities or things, and so we want to keep it as a fraction over of one number over another. Okay, and it shows how much greater one quantity is versus the other. So let's use the example of we want the ratio of stars to hearts. Okay, so how many stars are there? There's 3. And how many hearts are there? There's 2. So that's the ratio of stars to hearts. Whatever comes first, they want on top, and whatever comes second, they want that number represented on the bottom. Okay, whether it was the bigger or smaller amount, put it in the order that it comes. Now, this is one way to represent the ratio of stars to hearts. And again, don't reduce it to 1.5. I know that this fraction can simplify to 1.5, but when we're using it as a ratio, we want to keep it as a single number over a single number. Okay, now the other way to represent that is to separate it by the word 2 or to use it as a colon. Okay, these are all technically said the same way, 3 to 2, 3 to 2, 3 to 2. But we just wrote it represented a different way. This is most common because we can reduce this easily and stuff and use this to help us find missing pieces. But if we're typing it out, like, in a word problem or something, they might see this. And I want you to know that these two things are saying the same thing as this. We're comparing 3 to 2. Okay, now as we said, we most commonly use this one because it's easier to, if we wanted to create equivalent ratios. Equivalent ratios are kind of just like equivalent fractions. They're ratios that reduce to the same value. Okay, so again, just like equivalent fractions. You can find them by either multiplying or dividing by the same number to both the numerator and the denominator. So you can multiply or divide by whatever you want as long as you do the same thing to both the top and the bottom. So for here, for instance, let's say I were to multiply it by 2, then multiply this by 2. I can do that because essentially 2/2 is just 1, right? So I'm multiplying 2/5 by 2/2 or 1, and multiplying something by 1 doesn't actually change the value. So now when I do 2 times 2, that's 4, and 5 times 2 is 10. So 4/10 is equivalent to 2/5 because they both reduce to 2/5. And you can technically multiply 2/5 by whatever you want as long as you do the same thing to the top and bottom. So whenever they ask for these, I think the easiest one to do is times 10 because you're literally just tacking on a 0 to each of the numbers. right? So 20/50 is still equivalent to 2/5 because this reduces to 2/5. And I did the same thing to both the top and the bottom. And we said you can multiply the top and bottom by the same number, and you could also divide the top and bottom by the same number. So I could reduce both of these ones by 3, and I would get 3/4. And 3/4 is equivalent to 9/12 because 9/12 reduces to 3/4. Okay, or again, we could multiply them both by the same number. And 9 times 2 is 18, and 12 times 2 is 24. So 18/24 is equivalent to 9/12 because both of these reduce to 3/4. The only hint I have for you when you're creating equivalent ratios is technically, yes, you could have used 3/4 and gone from there and like maybe multiplied both the top and bottom here by 2 or by 10. But let's say I made a mistake reducing this to 3/4. If I based my next equivalent fraction off of 3/4 and it was wrong, then this one would be wrong too. So if this were a test problem, I just suggest to always use the ratio that you were given of 9/12 to then use that to multiply the top and bottom by the same number when creating your next one rather than one that you found. Because if you made a mistake on this and then you use that to create your next one, this one's automatically wrong too. So always try to use the one you were given if possible to create your next one. Okay, our next thing we're going to go over is a rate. A rate is a comparison, again, between two different quantities. But what's different of that versus a ratio is that they have different units. So for this, like you might have miles, hours, money, minutes, okay, any of those types of things, right? And examples of some rates would be like, how much money you earn per hour, or how much it costs per pound, or how many miles something goes per hour, or how many feet per second somebody can run, anything like that. And then, hint, remember that usually, not always, but usually, distance will go over time if you're stuck. And money usually goes over the number of items. So usually that little trick will work, that distance is on top, times on the bottom, and money will go over the number of items. But I'll also show you another trick when you're trying to use a rate to help you solve a problem, how you can determine what goes where. Okay, but first off, this one's just saying Samantha rode her bike 8 miles in 34 minutes, so express each rate as a fraction. They didn't really give us any hints, so if we have to guess, what makes more sense? Miles per hour or hours per mile? Miles per hour is what we say, right? And you're like, but wait a minute, you said like it's minutes here, not hours. Yeah, but minutes is kind of just like hours, right? So I kind of manipulated it to say miles per hour so I could see which way made more sense. It makes more sense if miles is on top and my time is on the bottom. But instead of hours, this time they said minutes. Okay, so we rode her bike 8 miles in 34 minutes. Okay, and there you go. That's a fraction. And then usually they want these reduced as much as possible. So what can go into both 8 and 34? 2 can. So 8 divided by 2 is 4. So 4 miles on top. And 34 divided by 2 is 17. So she rode her bike about 4 miles every 17 minutes. Okay. The next one says Lexi paid $13.94 for 24 batteries. So $13.94 for about 24 batteries. And I mean, we don't really need to reduce that one. You could reduce it by 2, but whatever. We'll just leave it like this. So this is me writing it as a fraction. It didn't specify lowest term, so fine. We'll just say that this is the rate. You paid this much money for that many number of items. Okay, let's get a little bit tougher here. Okay, sometimes you'll be asked to find the unit rate. Now, a unit rate is a specific type of rate where the denominator is 1. Okay. So again, it is, let me change out my pen here. It's a specific rate where the denominator is 1. So let's go ahead and cross that off. I think that's a typo. You can use this to find like the cost of a single item or the average speed, etc. So for instance, let's try to identify which ones of these are just rates and which ones of these are unit rates. Okay, well, what did we say about a unit rate? What makes a unit rate? The fact that the denominator is 1. So let's look at the denominators. Okay, that has a denominator of 1. No, that's just a rate. This is, well, okay, let's reduce it. Even if this was reduced, you still have 1 over 3. So nope, still just a rate. 60 miles for 1 hour. So yep, that's a unit rate. Okay, 99 cents for each apple. So unit rate. 32 miles per, it's implied 1 hour. So unit rate. And 1 kilometer per 12 seconds. Now the trap is a lot of people say, oh yeah, 1, but 1 needs to be in the denominator. So if it was like 12 kilometers per second, then yes, it would be a unit rate. But because the denominator is 12 seconds, it's just a rate. Okay. Now these ones are asking us to find the unit rate. So that means they want the denominator to become 1. Now, most of the time they give it to you in the correct order, but not always. So we need to look for context clues sometimes, okay? If they just say find the unit rate, oof, they didn't really give me any context clues, huh? So you have to think what normally goes on top. Well, money usually goes on top. So $4.80 for 12 bottles of water because it's a 12 pack. Okay. Well, if I want to find the unit rate, that means they want to know how much is it for 1 water bottle then if you buy it in a 12 pack. Well, I want the denominator to become 1, right? So how much is it for 1 bottle? Well, how do you go from 12 to 1? If I were to divide by 12, and I can do that as long as I do the same thing on top. So I'm going to divide 4.8 by 12, and I get 0.4, but I want it to be money, so 0.4 is the same thing as 40 cents. Okay, so it's about 40 cents per bottle if you buy a 12 pack versus if you buy it in a vending machine, it's like $1, $1.50, $2. So it's smarter to buy a 12 pack. Okay, for my next one, it says there are 1,096 calories in 8 cups of ice cream. How many calories are in 1 cup of ice cream? So because they said how many calories are in 1 cup, that's what they want me to have become 1, is the cups of ice cream. So that was nice of them. They kind of gave me the hint of what goes where. So I want the cups of ice cream to eventually become 1. And there's 8 cups of ice cream, and how many calories for that? There is 1,096. So if I want the cups of ice cream to become 1, so how many per 1 cup? How do you go from 8 to 1? You divide by 8, right? Because anything divided by itself is 1. But if I divided the denominator by 8, I need to also divide the numerator by 8. So 1,096 divided by 8 is, type that into your calculator, 137 calories. Okay, so how many calories are there per cup? 137. Okay. Now to get a little bit even more trickier is I'm going to have to find the unit rate to then answer a question. Okay, so right here it says Luke can run 1 mile in 8 minutes. If he continues at this pace, how many miles can Luke run in 56 minutes? My hint to you when deciding what to do, because like, yes, you could use those hints that normally work. Money usually goes on the top. Distance usually goes on the top, and time usually almost always goes on the bottom. Okay, but sometimes it doesn't. So maybe some of these will follow the rules and maybe some of them won't. So what the biggest hint I can give you is they're going to give you 3 pieces of information. Okay, the first 2 pieces of information will come within like the first sentence and they go together, right? And then that third piece of information will be in the second sentence with your question. So it'll give you one thing, like it gave me 56 minutes. And then it'll ask me something else, like how many miles then can he go if he ran in 56 minutes? Well, the thing that they give me 2 of, so minutes was given twice, right? 8 minutes and 56 minutes. This is going to go on the bottom. The minutes will go on the bottom then. So whatever they give me 2 of, whatever unit they give me 2 of, that goes in the denominator. And then the thing that they're asking about, how many miles, that's what's going to go in the numerator for this first part when you're deciding what to put where to find your unit rate. Okay, so what I mean by that is this. Okay, in that first sentence, we have miles and we have minutes, right? When deciding which one goes where, well, I see minutes again. So this is going to go in the bottom. So where minutes, right there, those are going to go in the bottom. So 1 mile for 8 minutes. Okay, now I need to find the unit rate of that. So how do I know how many miles I can go per minute? Because if I can find how long I can go per minute, then I could, well, if you can go that far in 1 minute, then multiply it by 56 minutes, and that will tell me how far you can go. So how do I go from 8 to 1? If you divide by 8, and whatever you do the bottom, you do the top. Okay, so basically it's 1 divided by 8, 1/8, or if you type that into the calculator, it's 0.125. So you can go 0.125 or 1/8 of a mile in 1 minute. So then if I want to know how far I can go, this is the unit rate, then use your unit rate to figure out how far you can go in 56 minutes. Now, since these are diagonally across from each other, these minutes, okay, they cancel. You're like, what does that mean? Let's say, for instance, I had a fraction like this, okay? 7/4 times 3 sevens, right? Well, do you see that sevens are diagonally across from each other? So you'd reduce them. 7 divided by 7 is 1. 7 divided by 7 is 1. So these cancel out and just become 1, and you're left with this. 1 times 3 is 3, and 1 times 4 is 4. So the sevens canceled out and almost like went away, right? And I was left with the other things. So I'm going to use that same type of logic for here with my units. I'm going to put these minutes diagonally across from each other so that they cancel. And now I'm just left with the unit of miles, which is what I wanted because it said, how many miles can you go? And now I just multiply those numbers, 0.125 times 56. Well, 0.125 times 56 is 7. So you can go 7 miles in 56 minutes. So again, first of all, I found my unit rate, and I found the unit rate of how far you could go in 1 minute because I wanted to know how far you could go in 1 minute. So then I could do that times 56, right? Because how far could you go in 56 minutes? All right. That same type of logic we're going to use to solve this next problem. And remember, you're always welcome to pause the video, try it yourself, and then unpause it and come back to check. Okay, it says 1 package of strawberries. So 1 package costs $4. Okay, now I don't know which one I'm going to decide where goes on top or bottom. But my hint is it says how many packages can you buy for $12? Okay, remember how we said whatever they said twice is what's going to go on the bottom. So my unit of money is going to go on the bottom. And then it says how many packages, so that's going to go on top. So that first sentence said one package costs $4. So I want to find the unit rate of how many packages I can get for just $1. Well, how do I go from 4 to 1? I divide by 4. And whatever you do the bottom, you got to do the top. So what's 1 divided by 4? 0.25 or 1/4. So you can get a fourth of a package for $1. So then if you can get that much for $1, how much could you get for $12? Okay, well, the unit of money cancels out, and now I'm just left with the unit of packages, and on top, 0.25 times 12. Well, 0.25, or a fourth, times 12, a fourth of a 12 is 3, and I'm left with the unit of packages, which is what I wanted, because it said how many packages could you get for that much money? I could get 3 packages. Okay, if you haven't tried any on your own yet, why don't you at least try the next 2 and then come back and join us once you've got them. Okay, so you paused it, you did it, you unpaused it, you're back with us. Let's see how you did. It says Bobby earns $120 by doing what? Shoveling 6 driveways. Okay, which one do I put where? Money usually goes on top, but let's see if this is one of those. Because here was one of the few times that money went on the bottom. It says, how much will he earn if he shovels 10 driveways? So the number of driveways is going to go on the bottom, and then what we're solving for goes on top. How much? So money goes on top. Finally, it follows the rule. And number of driveways goes on the bottom. So they said 6 driveways for $120. So let's find how much it is for 1 driveway, and then we can use that to figure out how much you'll get for 10 driveways. So how do you go from 6 to 1? We'll divide by 6. And whatever you do to the bottom, you got to do the top. So again, you divided 6 by itself so you could get 1 driveway. And then because you divided the denominator by 6, you divided the numerator by 6. And 120 divided by 6 is $20. So he gets $20 per driveway that he shovels. So then to figure out how much he would get for shoveling 10 driveways, okay, put those across from each other so they cancel out. And now you're just left with the unit of money, which is what we wanted. And 20 times 10 is $200. So he would make 200 smackers if he shoveled 10 driveways. Maybe we should start doing that. Okay, last one. So if you missed the last one, hopefully you got this one right. Okay, we're talking about if Sam could buy 4 pounds of apples, so we have the number of pounds of apples, for $2.50. Then it said how many pounds, so whatever you're solving for goes on top, for $8.75. Okay, so money's going to go on the bottom this time. Okay, so the thing that they gave me that goes together was that it's $2.50 for 4 pounds of apples. So if I wanted to know how much I could get for $1, well, I would need to divide by 2.5 or 250 because anything divided by itself is 1. And then do the same thing on top, divide it by 2.5, and 4 divided by 2.5 is 1.6. So you could get 1.6 pounds for $1. So then if you had $8.75, okay, how much could you get for that? Well, the units of money cancel then, and now you have 8.75 times 1.6, you get 14. And my unit that's left is pounds. So you get 14 pounds for $8.75. And that's how we use unit rates to help me find problems, the answer to problems. So again, my hint to you, whatever they give you 2 units of, so they gave me minutes and minutes, so minutes was on the bottom. They gave me money and money, so money was on the bottom. Number of driveways was given twice, so driveways was on the bottom. Money was given twice, so money was on the bottom. And then whatever like goes together, that's your first fraction. So 1 mile in 8 minutes, one package for $4, $120 for 6 driveways, and 4 pounds of apples for $2.50. I use that to find my unit rate. So you divided by whatever was in the denominator to become 1. And then you did the same thing to the numerator. Once you had your unit rate, like something per one, something per one, something per one, something per one, I used that with my second piece of information, which was like 56 minutes, $12, 10 driveways, and $8.75. And these units were always diagonally across from each other. They canceled out, and then I was left with the unit I was solving for. And then those two numbers just got multiplied together. All right, hopefully now you are a little bit better at ratios, rates, and unit rates.